Alright guys, so today I'm going to be talking to you about functions and relations, which is actually a very easy topic. We're just going to talk today about figuring out the difference between those and recognizing the difference between those, looking at different ways to represent them. So I'm going to first give you a list of 5 ways to represent functions. The first way is what's called a mapping. Okay, and that's what you see going on down here, so I'm going to write some things in here in a minute and show you how mappings work. Looks kind of like a Venn diagram, but it's not. The second way is to list ordered pairs. So if you're looking at a graph or a chart, ordered pairs are an easy way to represent a function or to determine if an equation is a function, is to look at the ordered pairs associated with it. The third way is a table of values, which is very similar to the ordered pair. You should be able to go back and forth between those two. Okay, so I'm talking about like an XYT chart here and you know, X comma Y for your ordered pair. So you should be able to move fluidly between those two. The fourth way is an equation, which is the way we are most used to looking at functions and relations, is working with equations. And the fifth way is graphs, and that's probably the second most used way to represent functions. Okay, so first let's look at what we call a mapping. And a mapping uses 2 sets of circles, in which one circle you're going to put your inputs and one circle you're going to put your outputs. Okay, and so here's an example of that. Like I may have 1, 14, 10, 5, and I may have the numbers 1, 2, and 3 over here, and all you do for a mapping is draw arrows between the inputs and the outputs. Okay, so simple. So a mapping can have 2 inputs that go to the same output. Here's another example of this. There are 34 of you in this class, so say students are my input, and say the school that you go to is your output, and so all 34 of you would be tied to MHS. Okay, so you can have a whole list. I could list everyone's name, like I could put Caleb and Riley and Bella, and every single one of you guys would be mapped to MHS. Okay, so that's a mapping. You can easily take any of these and go to a mapping. Okay, because if you can build a T-chart for it, you can map it. Okay, so the difference between a relation and a function. A relation simply shows that there is a connection or relationship between the 2 sets of points. Okay, so we could have, if I drew another mapping, sorry, this is kind of terrible. A relationship simply shows that these guys are related to these guys somehow. So, like, I could list you guys over here. So I could put Austin and Brody and Cheyenne. And then I could put eye color over here. So that's a relationship. So we could brown, blue, green. Okay, and we could literally map you onto what color eyes you have. Now, I don't remember what color eyes you have, but this is just an example. Okay, so it just simply shows there's a relationship or a connection. Okay, the domain is the first set of elements. So the domain would be you guys. Okay, it is the X values when you're talking about graph. Okay, the range is the second set of values, and it is the Y's if you're talking about a graph on a coordinate plane, or a set of XY, ordered pairs, etc. Okay, So we know these words domain, we know this word range. A relation is just showing that whatever is in the domain column is related to what is in the range column in some way, okay? All right, a function, so here, this is super important, okay? So let's make sure we get this definition. A function is a relation in which each x is matched to one and only one y in the range, okay? So each x can only be matched to one y, okay? So let me give you an example of that. Let me give you an example of what is a function and what is not. So these guys are function, and by the way, fxn is sometimes the abbreviation for function. So this is a function: 1, 2, 2, 5, 3, 7, 4. Hitting the button. 4, 9. Okay, that is a function, not a function. Okay, so we could have 1, 2. And 2, 5, just like we started up here. But then if I have 2, 7, you see how the 2's repeat? Okay, that makes this not a function. Okay, each x is matched to one and only one y. This x is matched to two different y's, a 5 and a 7. Okay, so that's what we're looking for if we're looking at a mapping, ordered pair, an equation, etc. You're looking to see if one x is matched to multiple y's. Okay, so let's look at a couple of examples and talk about domain and range. So ways to roll a pair of dice. So we're rolling 2 die. Okay, so I'm not gonna list all of these because there are actually 36 ways to roll a die, but we can have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Okay, and then we can have 2, 1, because that's different, left die, right die, or blue die, red die, 2, 2, 2, 3, etc. And then you would have 3, 1, etc. and 4, 1, and then 5, 1, and 6, 1. Okay, all the way. Okay. So there are 36 total ways. To roll a pair of dice. Okay, now what if we are talking about just rolling a 7? So if you roll a 1 on your first die, the second one has to be a 6, right, to get a 7? What about 2? So 2, 5, and 3 is 3, 4. Okay, and then if we roll a 4 the first time, we would have to have a 3 on the second. A 5 the first time gives me a 2 on the second, and a 6 the first time gives me a 1. So there are 6 different ways to roll a 7. So now let's talk about the domain and the range of each relation. Okay, so let's look at this first, the ways just to roll a die. A pair of die. Okay, so the domain. Talk to me about the numbers in the domain. Well, if we look, we have 1, 2, 3, 4, 5, 6. So we can do a couple different options. So the first way that we can write this, okay, is just a list of the elements. So 1, 2, 3, 4, 5, 6. Okay? And the range would be the same, right? Think about that for just a second. The range would be 1, 2, 3, 4, 5, and 6. Okay? A second way to write is what's called set builder notation, and here's how we write that. We say X, do the squiggly bracket, such that, that's what this line, that's how you read that in math, x such that. Now, x is, here we're going to put an inequality to represent this 1 to 6, okay? So we could write that like x such that 1 is less than or equal to x is less than or equal to 6. So my x is between 1 and 6. You could write the same way for the range, except now we're going to switch to a y. So y such that 1 less than equal y less than equal 6. Okay? So one way is just to list the numbers. It's just a list. The second way is what's called set builder notation. That's this one and this one. The last one is interval notation, and you guys know that. We've talked about interval notation. So this would be a closed dot on 1 because we can choose 1 all the way to a closed dot on 6. Same for the range, 1, 6. Okay, so 3 different ways to write domain and range. We're going to do a whole day on domain and range, so don't worry about this yet, okay? I think there's a couple of questions, but just do whichever way makes the most sense to you, okay? All right. So let's go from a table of values and do domain and range. So normally when I'm here, I actually do this with you guys, but today we're just going to make up some data. So we're going to say eye color and number of students who have that eye color. Okay, so eye color, blue, green, brown, hazel. We're just going to go with those. All right, so blue, let's say there's 6 of you with blue eyes, and 7 with green, and 10 with brown, and 5 with hazel colored eyes, okay? So if we were going to list the domain of this, the only way to list this domain, because the domain is words here, is to do a list. So blue, comma green, comma brown, comma hazel. Okay, the range, because these are not continuous values here, we are going to list them just like this. And you can put them in numerical order if you want to. Now let me point out something here. If this had been a 6 as well for hazel, if we'd had 6 people with hazel eyes, we would not list the 6 twice for the range. We'd only list it one time. We would just know that 2 things were mapped onto the 6, okay? All right, so let's look at the next part, because this is where we start using a little bit of algebra to determine from an equation if something is a function, okay? All right, so I'm going to give you a second just to write down these equations really quick, and then we'll go from there. All right, so here's what you need to look at. First, you need to get y by itself. You see if there is a plus or minus. If there is a plus or minus, it is not a function. Okay? It is not a function if you're adding a plus or minus. So we're going to get y by itself right here. Y is equal to, so minus x, negative x plus 9. So I want you to think about this. What is this graphically? If I were to graph this on the coordinate plane, this is a line through positive 9 with a negative slope. Okay, this is a function. This is a function. Okay? All right, let's look at this next one. Again, y by itself. So subtract x squared, subtract x squared. So y is equal to negative x squared plus 9. Okay, so what we're looking at here, we know that this, if we graphed it, is an upside down parabola, looks like this. Okay, this one is also a function. There is no x that is matched to part of a graph up here and part of a graph down here. All right, here's where things get a little tricky. If we look at this next one, minus x, I get y squared equals 9 minus x. Then what do I have to do to get rid of the squared? I hope that you said square root both sides, because look what happens here. Y is equal to plus or minus square root 9 minus x. Here's that plus or minus. This one is not a function. Not a function. Okay? All right, I want you to try this one. Alright, so on our last one over here, we should be minusing x squared minus x squared. So I get y squared equals 9 minus x squared, square rooting again. So there's that plus or minus that's going to pop out. 9 minus x squared. Okay, so this one is a no, not a function. Alright, let's talk about this. Alright, we know if we subtract, this is absolute value, right? Okay, so we get y equals negative absolute value of x plus 9. I hope you remember graphically that this is a V-shaped graph. Sorry, that's a terrible V. Okay, this one is a function. But when we come over here, this one looks a little bit different. If I minus this x and minus this x, I get absolute value of y equals 9 minus x. Well, this is not, y is not solved for, but remember absolute value means distance from 0. So what I'm really talking about is that y is 9 minus x units from 0, and y is also negative 9 minus x units from 0. So there's your minus and there's your plus. So this one is not a function. And if you were to graph it, it would look like this V, except it would be turned this way if we were to graph it. But what we're really looking for when we're looking algebraically is there a plus or minus that pops out? Like this one here, here, and then this positive or negative. So if you look where do plus or minuses come from, taking an even root, so if this had been a fourth root would pop a plus or minus, square root pops a plus or minus, absolute value pops a plus or minus, okay? And that's absolute value on the y, even roots on the y, okay? All right, a couple more things and we're done. All right, graphically, to me, this is the easiest way to tell if something is a function or not, okay? The vertical line test, that's what VLT stands for, vertical line test. Basically, you're taking a vertical line and you're laying it across the graph to see if it hits the graph twice. So the vertical line test, you lay a vertical line across the graph and look for 2 touches. Look for 2 touches. Okay, so here's some examples real quick. These are really easy. If I can draw a bunch of vertical lines, and my lines aren't super vertical, and only touch the graph one time. See here, touched it. Each line only touches once. Then this is a function. Okay, so now you can see pretty clearly that this one, 2 touches, not a function. Okay, look at this guy. Vertical line, bunch of vertical lines you can draw here. Vertical line, vertical line, vertical line, vertical line, so on and so forth, is a function. Okay, look at this guy up here with all the crazy asymptotes. Okay, we start drawing vertical lines, we're still only touching it once. So this one is a function. Okay, look at this last one. It's kind of deceptive, but if I start drawing vertical lines here, I'm okay. What about here? Although I touch the graph, do you see one is open and one's closed? So that one's okay, but look at this. Ooh, that was terrible. Not even a vertical line. If I draw a vertical line right here, do you see how I touch the graph twice? This one is a no, not a function. Okay? Not a function. All right, so pretty simple stuff. All you're going to be looking at is, can I draw a mapping? Can I decide from a mapping if it is a function or not? Can I decide from a graph? Can I decide from an equation? Okay? So here's what I want you to do. I want you to try these really quickly, and I want you to tell me function or no function. And here's what you're looking for. No repeated x's. No repeated x's. Can we have repeated y's? Yes. Can we have repeated x's? No. Okay? So put on your paper 1, 2, 3, 4, 5, and tell me yes or no. Alright, so let's look at number 1. If you look at your x values, are they all different? They are all different, so this one is a function. Okay? What about this one? Again, look at your x's. Are they all different? Yes, so this one is a function. Same one here. Look at your x's. Are they all different? Yes, so this one is a function. What about this one? Check out, do you see how this 3 goes to 2 different y values? Okay, if we were to write this as ordered pairs, it would be 1 comma A, 2 comma D, 3 comma D, 3 comma C. There's your repeat. Okay, so this one is a big fat no. Okay, I saved number 2 for last on purpose because I want you to read the directions. Do you see, is the relation a function from A to B? Okay, do you see how the A's are here in the second ordered pair spot, which is kind of backwards from how we normally, so we are looking from A to B. Do the A's repeat? Do the A's repeat? Okay, so if we look here, do you see how you have double A's that repeat? So this one is a no. No, it's kind of tricky because if you look at the B's, they're okay, but they're talking about strictly a function from A to B. So be careful. I think there's one like that on your worksheet tonight. All right, so you have enough information to do the first worksheet on functions, which is pretty easy, and we will check that on Monday when I get back. Hope you guys have a good weekend.